Okay, so the procedure begins. We're going to have a known resistance that will serve as the internal resistance and then verify that the power is maximized when the load resistance matches this value. So we've got the basics of the circuit set up. We have our DC power supply. And so the red is going into the DMM that we're going to use to measure current. And then it's going to be connected to the first resistor. This is going to be called the internal resistance. This is the known resistance. We've set it up so that the reading on the digital multimeter we get is 2.70 or 0.270 kiloohms or 270 ohms, which is the value that we want. We actually had to set the reading to 269 to get it, so it's off by about an ohm. So we know the uncertainty is about an ohm with these resistances, but that's still acceptable as far as this goes. So now that we've verified the resistance, what we are going to do is keep that digital multimeter. We're going to use that to measure voltage now. But we're going to connect this meter. This is going to be our variable resistance. So we're going to keep this one constant. This is our internal resistance, and this is going to be our load resistance, which we are going to vary. And what we should see is that the power coming out through this resistor is maximized when its resistance, or the resistance here, equals the total internal resistance. So we've got 270 ohms here, and there may be some internal resistance in the power supply or in some of the other pieces of equipment. So the resistance might be maximized at a number a bit larger than 270 ohms. But that's for you to determine. So we're going to set up the procedure. So we're going to start with an initial value of 20 ohms. And so that's going to be the load resistance. And so we're going to set up the voltmeter. And let's see. I guess the first thing we want to do is get power out of the supply. So we're going to set that to 1.5 volts. So we turn this on, and we dial up the knob, and we want to get a voltage reading out here of 1.5 volts. All right, 1.5 volts, that's perfectly good. So now we're going to connect that to our resistor, which is currently at 20 volts, and I apologize if you can't see much right now. So that's 20 ohms is that resistance, and we're getting a voltage out of 0.10 meters, and you see the current is 0.50 milliamperes. And so that's that'll be 4.94 milliamps. And so that's 0.10 volts coming out here. And so we're going to take 5 points between 20 and 100. So that's the first thing we're going to do. So these are our readings at 20. And so you're going to record for each point the resistance, and this is the load resistance, capital R, the current that you measure, which is over here, and then the voltage across the load resistor, which is over here. And so the procedure is actually fairly simple, but it's a little bit time consuming. There are a lot of steps. So that was 20 ohms. So now we're going to go to 40 ohms. So the load resistance is 40 ohms. The current is 4.59 milliamps. And the load voltage is 0.18 volts. Now we're at 60 ohms. 4.33 milliamps, 0.26 volts. That's 80 ohms. We'll go with 4.09 milliamps and 0.33 volts. And then we'll do 100. So now we're at 100 ohms. That's 3.87 we'll go with. And that's 0.39 volts. And so the 3.85 we're at now, that's the milliamps. So now we're going to do 40 points between R is equal to 100 ohms and R is equal to 500 ohms. So we're going to work in 10 ohm increments. And so this is going to take some time. So that's 110 ohms, 3.74 milliamps, 0.41 volts. 120 ohms, 3.65 milliamps, 0.44 volts. 130 ohms, 3.56 milliamps, 0.46 volts. 140 ohms, 3.47 milliamps, 0.49 volts. 150 ohms, 3.39 or 3.40 milliamps, 0.51 volts. 160 ohms, 3.32 milliamps, 0.53 volts. 170 ohms, 3.24 milliamps, 0.55 volts. 180 ohms, 3.18 milliamps, 0.57 volts. 190 ohms, 3.11 milliamps, 0.59 volts. Let's see if I can... Okay, so 0.593 volts. So we'll try to get three significant figures for everything. Not as important up to this point, but we're going to want to improve the precision now. So now we're at 200 ohms. Resistance, 3.04 milliamps, 0.612 volts. 210, 2.98 milliamps, 0.629 volts. 220, 2.92 milliamps, 6.46 volts. 230, 2.86 milliamps, 6.62 volts. 240, 2.81 milliamps, 0.678 volts. 250 ohms, 2.76 milliamps, 0.694 volts. 260, 2.71 milliamps, 0.708 volts. 270, 2.66 milliamps, 0.722 volts. 280, 2.61 milliamps, 0.736 volts. 290, 2.57 milliamps, 0.745 volts. And now we move up to 300. So 300 ohms, 2.53 milliamps, 7.61 volts. 310, 2.48 milliamps, 0.774 volts. 320, 2.44 milliamps, 0.785 volts. 330, 2.40 milliamps, 0.796 volts. 340, 2.37 milliamps, 0.809 volts. 350, 2.33 milliamps, 0.818 volts. 360, 2.29 milliamps, 0.829 volts. 370, 2.25 milliamps, 0.840 volts. 380 ohms, 2.22 milliamps, 0.850 volts. 390 ohms, 2.19 milliamps, 0.859 volts. And now we're up to 400. So we've got the bulk of the work done at this point. So 400 ohms, 2.15 milliamps, 0.870 volts, or 0.869 volts. 410, 2.13 milliamps, 0.878 volts. 420, 2.10 milliamps, 0.886 volts. 430, 2.07 milliamps, 0.896 volts. 440, 2.04 milliamps, 0.903 volts. 450, 2.01 milliamps, 0.912 volts. 460, 1.99 milliamps, 0.920 volts. 470, 1.96 milliamps, 0.927 volts. 480 ohms, 1.94 milliamps, 0.935 volts. 490 ohms, 1.91 milliamps, 0.943 volts, and then finally 500. And that's 1.88 milliamps and 0.949 volts. So then we're going to do 5 points between 600 and 3000. So we're going to start with 600 and then work from there. So 600, 1.67 milliamps, 1.010 volts. 1200, 1.00 milliamps, 1.208 volts. 1800, 0.71 milliamps, 1.292 volts. 2400, 0.55 milliamps, and 1.340 volts. And then 3000 to finish off with, 0.45 milliamps and 1.371 volts. So, and I didn't check if the voltage across the power supply was changing. Well, I can do that now and see if we've got a significant difference. So we were at 1.50 initially. So let's see if it's changed slightly. And no, it really hasn't. So those readings are good. So what you're going to do is you calculate the power over the load resistance, and we're going to do this two different ways. You're going to calculate it two different ways. One, you're going to multiply the current by the voltage you measured across the load. And so you can have a table for that, and you can set it up on Excel so that you do the calculation once and then fill down, and the computer will do all the other calculations for you. And in another column, you're going to do delta V squared divided by R. So you know what the load resistance is for each row in your table. And you've got the load measured, or the voltage across the load measured. So it's delta V squared divided by R. And they should agree reasonably well. If you find that they're not agreeing, that's something to comment on and try to explain what's going to happen, or why that happened. And so you're going to make a plot of the power across the load resistor versus the resistance, and determine the resistance that maximizes the power. And obviously we were working in 10 ohm intervals, so you'll only be accurate to 10 ohms. And so the value should equal 270 ohms plus the internal resistance of the power supply. So that should give you some idea whether there's a significant amount of resistance inside the power supply or not. So that's the basics of this experiment. And if I ran through it a little too quickly, feel free to pause going through. But if you have any questions about any of the steps or any of the concepts, do not hesitate to email me. Otherwise, I will see you with the next experiment.